Welcome back to STS. In today's video, we're going to look at the quotient rule, which is a shorthand method to using the difference quotient. With the quotient rule, let's write this using the derivative notation. Let's say d by dx of f of x divided by g of x, and the shorthand rule for coming up with this derivative is g of x times f prime of x minus f of x times g prime of x, where this entire numerator, this entire quantity in the numerator, is to be divided by g of x raised to the second power. And again, this here looks complicated, but when trying to do more sophisticated derivatives, it's much easier to use this quotient rule than it is to go back and use the difference quotient. So let's take a look at an example. Let's say y is equal to, and as a matter of fact, let me go ahead and change color so this is different from what I have above. Our we have a rational function here where the numerator is x to the third minus 4 and our denominator is 6x minus 2. So in this example, the numerator here is going to be denoted by f of x, and this denominator is denoted by g of x. So first things first, let's take the derivative of the numerator. All right, we're going to use the power rule on this first term here, where the 3 comes down to the front, and I'm going to decrement the exponent from a 3 to a 2. And we know that the derivative of a constant is 0, so I'm not going to write anything after this term. Now let's differentiate g of x. All right, we're going to look at the first term, which is 6x. Well, I'm going to keep my constant of 6, and I know this x has a power of 1, which I bring to the front, so 6 times 1 is still going to give me 6. And when I decrement this power from 1 to 0, I know x to the 0 is in fact 1. So 6 times 1 would just be 1. And then here I get to this constant negative 2. When I take the derivative of this negative 2, I know that there is also 0. So I'm not going to write that. Now I'm going to put this in place. So I'm going to write y prime is equal to g of x. Well, g of x is my denominator. So here 6x minus 2. And that's going to be multiplied by the derivative of f. And here we have 3x squared. And I'm going to subtract that from the numerator, which is x cubed minus 4, as I have denoted here, times the derivative of g. And the derivative of g we see is 6. All that over the g of x squared. So here g of x is 6x minus 2, and that quantity is squared. And just to simplify some, we're going to just start with the numerator here. I'm going to distribute this 3x squared to both terms. So 3 times 6 to give me 18. X times x squared to give me x cubed. Negative 2 times 3 to give me a negative 6. And then I have my x squared. And then on this side here, I'm going to I think the easiest thing to do is just to distribute this 6 to both terms. So I'll put my negative here, put my parenthesis or my square brackets, because I have a negative out here, and I know I have to distribute that. I'll do that in my second go round as I evaluate. So 6 times x cubed is 6x cubed, and 6 times negative 4 to give me a negative 24. And I'm just going to rewrite this denominator. I'm not going to expand that out. All right, with this numerator, my next step here with the numerator is I can distribute a negative to both of these terms. So I rewrite 18x to the third minus 6x squared minus 6x cubed plus 24. And notice I change the sign here and the sign here as I distribute that negative. And all of this again is divided by that 6x minus 2, where that quantity is squared. And now let me look to my numerator to find like terms and simplify from there. So here I have two terms with x to the third. So I do 18 minus 6 to give me 12x to the third. So those go away. And then I have a negative 6x squared that can't be simplified plus a 24, and I keep my denominator of 6x minus 2 quantity squared. Alright, so this here is in fact the derivative of the initial equation that we have here. Now let's go ahead and do one other example. In this next example, we're going to, well, matter of fact, let me go ahead and add a new page here. In this next example, the function is y is equal to 1 over 2x cubed. The numerator I'm going to look at as f of x. The denominator I'm going to look at as g of x. When I do f prime of x, well, the derivative of a constant is just 0. G prime of x, well, I'm going to keep my 2 as a constant out front, bring down my power of 3 to the front of my this factor here, and I'm going to decrement the power, so x to the third actually becomes x to the second. And as I continue to simplify, 3 times 2 to give me 6, and I've got the x squared. All right, now to find the derivative. With the derivative, I go ahead and I write the denominator first, which is 2x cubed, and that's going to be multiplied by the derivative of the numerator, which is 0, minus, now I'm going to write the numerator, which is 1, times the derivative of the denominator, which in this case is 6x squared, and I take the original g of x, and that has to be squared. So 2x to the third, and that quantity there is squared. Now I begin to simplify. 0 times this quantity here is 0, and then I'm left with negative, and I've got 1 times 6 to give me 6, and I've got the x squared left. And for this denominator, it's easily squared. So 2 to the second is 4, and x to the third raised to the second. When I have an exponent raised to a power, I end up multiplying the exponent, so this here is actually x to the sixth. And then I can simplify what I have here. I have two even numbers which can both be divided by 2, so that there becomes a negative 3 halves. And then I've got 2 x's at the top and 4 x's at the bottom. That simplifies down to just x to the fourth in my denominator. So this here is the derivative of this function here using the quotient rule. But I want to also go ahead and show how this here can also be solved using the power rule. So here I'm going to rewrite this as 1/2, and I'm going to use a negative exponent because I'm going to move this x to the third from the denominator to the numerator. So this here becomes x to the negative 3. I have a constant of 1/2, so I can pull that out front. I know that using the power rule, this negative 3 has to be pulled to the front. So I've got my negative 3. And then I have to decrement this power. Well, if I've got x to the negative 3 minus 1, that changes this to x to the negative 4. And as I continue to evaluate, 1/2 times negative 3 is actually negative 3 halves. And then x to the negative fourth, that actually moves to the denominator, which becomes which is going to become 2 times x raised to the fourth power. And let me just try to write this fraction bar in here a little bit better. Alright, so we see that using both methods, we still get the same results. And this here was a combination of the constant multiple rule and the power rule. Alright, so that sums it up for this video by STS. Please friend us on Facebook and also subscribe to our YouTube channel, where you can stay informed on all our new videos and any updates to our page. And as always, thank you for watching.